Welcome students to Kent Public High School and Boys College, Father Colony, Texla Kent. Subject Chemistry, Chapter number 10, Acid, Bases and Salts. Topic is Strong and Weak Acids and Bases, Neutralization Reaction, pH Scales, and Indicator. Strong acid. Strong acids are those acids which completely break down to give off many hydrogen ions. Strong acids are amused to dissociate completely when in aqueous solution. Weak acids. Weak acids only partially break down to give off H plus ion. Weak acids dissociate only slightly in aqueous solution. The majority of molecules remain undissociated. Strong and weak bases. Strong bases. Strong bases are all strong electrolyte that ionize, dissociate completely in solution. For example, NaOH, when dissolved in aqueous solutions, gives off Na plus OH minus ion. Second example is KOH, potassium hydroxides, when dissociates completely in solution, it gives off K plus ion plus OH minus ion, hydroxyl ion. While in case of weak bases are bases that ionize only to limited extent of water. Examples: NH3 plus water gives us NH4 plus OH minus hydroxyl ion. Common acids. In common acids, strong acids, first of all, sulfuric acid, formula is H2SO4, hydrochloric acid, HCl, hydrobromic acids, HBr, hydroiodic acids, HI, nitric acid, HNO3, perchloric acid, HClO4. All other considered weak. For example, weak acids are acetic acids and carbonic acid. Common bases. Some common strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, barium hydroxide, calcium hydroxide, and strontium hydroxides. Hydroxides of group 1 and group 2 metals are strong, all other are weak. Likewise, some bases, very few, don't have OH ion, most commonly ammonia, NH3, as an example. Neutralization. Reaction between acid and bases. When an acid and a base react with each other, the characteristics properties of both are destroyed, and this is called neutralization reaction. In acid-base reaction, general formula for acid and bases reactions are as acid plus bases gives off water and salts. Salts mean any ionic compound formed from an acid and base reaction, but not just in NaCl. In neutralization reaction, when HCl acids plus NaOH base react with each other gives off water H2O plus NaCl salt. Likewise, another example of neutralization reaction is when HNO3 plus KOH react with each other gives us H2O plus KNO3 salt. Indicators. An indicator is a compound that will change color in the presence of an acid or base. While in red litmus turn blue in base, blue litmus paper turn red in acid. Universal indicator. Universal indicator is called pH paper used for the full pH ranges. For example, phenolphthalein turn pink in a base. pH. pH stands for potential hydrogen and is a measure of how many hydrogen ions there are in solution. The more hydrogen ions there are, the lower the pH will be. Litmus paper. Litmus paper is used to determine whether the solution is acidic or basic. Litmus paper are of two types, red and blue. Acid turn the litmus paper to red and a base turn litmus paper to blue. pH scale. It is the scale which helps to know about the acidic and basic strength of a compound. It varies from 0 to 14. If the pH is less than 7, the solution is acidic. If the pH is greater than 7, then the solution will be basic. If the pH of a solution is equal to the 7, the solution will be neutral. The acidic solution will have more number of H plus ion, while basic solution will have more number of hydroxyl ion in comparison. Likewise, as I said earlier, pH scale show the ranges of hydrogen ion concentration. In this figure, the hydrogen ion concentration would start from most acidic to most basic concentration. For example, higher concentration of H plus ion start from Cl. HCl, lemon also include certain plants at a particular pH ranges, while a low concentration start from pH 8 to 14, which include baking soda, ammonia, and drain cleaner, while distilled water is at pH 7. Digestion and pH. But before this, let us know about the process of digestion. That what is basically digestion? Digestion is a process by which foods are broken down into simpler substances. There are two types of digestion: mechanical digestion and chemical digestion. In mechanical digestion, the food is torn apart in mouth. It is a physical process, while in case of chemical digestion, in which a large molecule are broken down into simpler molecule. Chemical digestion takes place in stomach and small intestine. pH in digestive system. pH in digestive system start from mouth, pH around 7, where saliva contain amylase, an enzyme which begin to break carbohydrate into sugar. In stomach, pH around 2, where protein are broken down into amino acid by the enzyme pepsin. In small intestine, pH around 8, where most digestion ends. Small molecules move to bloodstream toward cells that use them. But what do you know about acidity of stomach? In digestive system, hydrochloric acid is a component of gastric juice. To activate the enzyme pepsin, almost 2 liters of it is secreted each day by gastric juices. However, sometimes too much acid is secreted in the stomach, which cause indigestion, and this condition is called acidity.